Hey guys, so welcome. Today we're going to be combining our exponent laws, our rational exponents, and our negative exponents, just to do some examples to give you guys an understanding of how to do harder problems. This video is going to have about 23 or so stick around, and I'll leave in the comments like every problem set, so you can go check that out. But without further ado, let's get started. 81 to the power of negative 1 over 4. First thing we see is a negative exponent, so we're just going to put 1 over 81 all to the power of positive 1 over 4, just like that. And then, since it's a rational exponent, we are just going to put 4 in the... we're going to use 4 as like the root. And basically, what is the fourth root of 1? Well, the fourth root of 1 is 1. And what is the fourth root of 81? Well, it's 3. So our final answer is 1 over 3. And for these questions, you're not really supposed to be using a calculator. It's supposed to be more show your understanding. But yeah, let's do the next one. So this one is just a fraction, but we have a numerator too. So we're going to take the fourth root of 81. And we're just going to put it all to the power of 5, just like that. So the fourth root of 81, like we just said, is 3. And 3 to the power of 5 is basically, let's see, 81 times 3, so 243. Just like that. Let's do the next. First thing, we see there's a negative, so we're just going to put 1 over 16, like that, to the positive 3 over 2, and then we're going to take the square root of 1 over 16 all to the power of 3. So the square root of 1 is 1, and the square root of 16 is 4 to the 3, and 1 to the power of 3 is 1, and 4 to the power of 3 is 64. And that's our final answer, 1 over 64. Let's move on. This one right here. First thing we see is a negative exponent. So we're going to do 1 over 4 over 81 all to the power of positive 3 over 2. Now 1 over 4 over 81, when you're dividing by a divider, what's really happening when we say dividing? If we do 1 divided by 4 over 81, which is exactly what we're doing, if you remember dividing fractions, we turn this into multiplication and we flip it. So then it becomes 1 times 81 over 4, which is just 81 over 4. I'm just going to go ahead and erase that for room. So 81 over 4 to the power of 3 over 2. Just like that. And now we take the square root, all to the power of 3. Actually, I'm going to move it over. I don't know if you guys could see that. And we get, what's the square root of 81? Well, 9. And what's the square root of 4? 2. We get 9 over 2 to the power of 3. So what's 9 to the power of 3? Well, 729. And 2 to the power of 3 is 8. Just like that. That's our final answer. Let's move on to number 5. I'm just going to erase that. So now it gets like a little bit complicated, because these don't have the same base, so we can't really add the exponents. However, if you notice, 25 is just 5 squared. So let's change it. This is 5 squared, and it's to the power of 4 over 9. Right? Because 25 is 5 squared. And now we have an exponent to an exponent, so we can do this. So this becomes 2 times 4 over 9, so 5 to the power of 8 over 9, times 5 to the 1 over 9. And now they have the same base, so we add the exponents. 8 over 9 plus 1 over 9 is 9 over 9, or 1. So 5 to the 1, or just 5, is our final answer. Moving on. This one right here. So we see that it has a, we see that it's the root of 5. So we just want to change this. 7x to the 4 to the power of 1 over 5. And now we just want to run that exponent through. So this becomes 7 to the 1 over 5, and then x, well, 4 times 1 over 5 is 4 over 5. And that is our final answer. When we're doing exponent laws and stuff like that, and like when we're solving, when we're simplifying, our final answer can't have negative exponents. That's the whole point of simplifying it. Anyway, let's move on to the next 6. Here, we have the third root of the square root of x to the power of 5. And it's kind of intimidating, but just take it step by step. So, let's do the inside first. The square root of x to the 5 is a different way of writing x to the 5 over 2. Right? Because the 2 would go as the square, and the 5 would be used as the exponent. So now that we have this, we can do it. Let's take the 3 and use it as a denominator. We're saying this is x to the 5 over 2, basically to the power of 1 over 3. Right? Just like that. Because this 3 is the same as saying 1 over 3. Just like that. So, now we have an exponent to an exponent, we can just multiply it out. So 5 times 1 is 5, and 2 times 3 is 6. And our final answer is x to the 5 over 6. And we can always check our final answers by subbing in a value for x. So in our case, I'm just going to say x equals 2. So if I sub that into the top, so we have 2 to the power of 5, and then we want to take the square root of that answer, and then we want to take the cube root of that answer. And I got 1.7. 7.9 actually. Well, 7.8. Just like that. So now if I sub 2 to the power of 5 over 6, I should get the same answer, and I do. 1.78, so on and on and on. And that's just an easy, quick check that you guys can always do, especially when like working with variables. Just sub it into your calculator. You don't need to show it. It just tells you that you did it properly. Because our exponent rules should say that this equals that, which it does. Let's move on to the next one. So the third root of negative 5x to the 4. So third root, again, is the same as saying to the power of 1 over 3. And now we can just take that 1 over 3 and run it right through. So negative 5 to the power of 1 over 3. And then here we have an exponent to an exponent, so we multiply, and it becomes x to the 4 over 3. Just like that. Moving on, let's do this one. 1 over, so 7th root is the same as saying 1 over 7, and since we have a 9, this can be 9 over 7. Now, depending on your teacher, depending on your class, everything like that, that would be acceptable, or we could write it as negative 9 over 7, since we have that 1 on top. These two are the exact same thing, really. It just depends on your teacher, how she likes it. But yeah, those would be our answers. Moving on, let's do this one. Again, it looks intimidating. Let's take it bracket by bracket. So the first one, we have a third root. So let's just take it and put it to the power of 1 over 3. And the second one is a fourth root. So let's take the inside and put it to a power of 1 over 4. And now from here, let's just run our exponents through. So 3 times 1 over 3 becomes 1. So this is x to the 1. 2 times 1 over 3 becomes 2 over 3. And we're multiplying that by this. So now let's do the same thing here. Negative 2 times 1 over 4, well, becomes negative 1 over 2. So x to the negative 1 over 2. And then 3 times 1 over 4 is 3 over 4. So from here, now we're just basically multiplying and same basis, so we can add our exponents. So 1 plus negative 1 over 2, or 1 minus 1 over 2, is just 1 over 2. So this becomes x to the 1 over 2, and then 2 over 3 plus 3 over 4, we actually need to change it, and I'm just going to do it on the side here. If you remember adding fractions, they need to be the same denominator. So 2 over 3 plus 3 over 4. And the same denominator in this case would be 12. So to 3 multiply by 4, well, 4 over 4. So 8 over 12 plus 9 over 12. And we get 17 over 12. So this becomes y 17 over 12, just like that. That's our final answer. Let's do the next one. Here we have a fifth root, and we also have it to the power of 4. Now, something you should be able to notice is that, okay, this becomes 2a3, b to the 4, c to the negative 2, all to the power of 4 over 5. Because the 5 would become the root, and the 4 would become the exponent of the whole thing. And now we can simply run this through. So 2 to the power of 4 over 5, and then a to the 3 times 4 over 5, so 3 times 4 over 5 becomes 12 over 5. b to the 4 to the power of 4 over 5, so multiply 4 times 4, 16 over 5. And then c to the negative 2, well, negative 2 times 4 over 5 becomes negative 8 over 5. This looks like a complete answer, but it's not, because we have a negative. So this would then become 2 to the 4 over 5, a to the 12 over 5, and b to the 16 over 5, all divided by c to the 8 over 5. Just like that. This would be our final answer. Because this right here becomes 1 over c to the 8 over 5. And when we multiply this whole thing by that, we just simply put it on the bottom. Let's move on to the next couple. So let's just simplify. So m to the 3 all to the root of 5. So that's the same as saying 3 over 5. So m to the 3 over 5 times, and then here 4, that's this whole thing is the same as saying m to the 4 over 5. So m to the 4 over 5, and here we have same base, m, so we can add the exponents. So 3 over 5 plus 4 over 5 is 7 over 5. And that is our final answer. Moving on. This one's a little tricky. It's kind of long, but when you see a question like this, the first thing you want to see if you can do is see if you can make everything into the same base. And in this case, I can. 27 is 3 to the power of 3, and 9 is 3 to the power of 2, and we already have a 3. So let's just rewrite it. So it becomes 3 to the negative 2 times, this is 3 to the 3 to the m divided by 3 squared to the negative m, all this to the power of negative 1, just like that. And then from there, let's just expand everything. So 3 to the negative 2 times, here we have an exponent to an exponent, so 3 to the 3m divided by, again we have an exponent to an exponent, divided by 3 to the negative 2m, all this to the power of negative 1. I'm just going to erase this because I'm going to run out of space. Just like that. And then from here, we can use our exponent laws. So when dividing exponents with the same base, we subtract, right? So this becomes 3 And what is 3m minus negative 2m? Well, then we add it. So 3m plus 2m is 5m. And here we're multiplying exponents with the same base, so we add them. Now, can we add negative 2 and 5m? No, we can't. But we can write it out like this. 3 to the... oh, oops. We can write it out as 3 to the 5m minus 2 to the negative 1. Just like that. And now this could either be our final answer, or we could just put 1 over 3 over 5m minus 2, anything like that. And yeah, that would be our final answer. Moving on, let's do this one. So here, it's a little bit different, because here we have a subtraction, and a lot of people will be inclined to subtract the actual exponents. However, that's wrong, like you shouldn't do that. So instead, what we're going to do is, we're simply going to solve it regularly. Negative 3 to the negative 2 times 3 to the 3 is 27, and 3 to the 4 is 81. And then negative 3 to the negative 2 is negative 1 over 3 squared times 27 minus 81. So 27 minus 81 is negative 54. From here we have negative 1 over 3 squared is just 1 over 9 times negative 54. Negative 54 over 9. Just like that. And I'm hoping you guys see that that can actually be simplified to negative 6 as our final answer. Because 54 divided by 9, well, is 6, and we had a negative in front. Let's move on to the next couple. So, here, we're just going to rewrite it. Okay? So 4 to the negative 1 plus 3 to the negative 2 divided by 3 to the negative 2 plus 2 to the negative 3. I'm just going to rewrite it like that. And from here, I'm going to work with what's in the brackets. So 4 to the negative 1 is just 1 over 4, plus 3 to the negative 2 is 1 over 3 to the power of 2, so 1 over 9. And we're dividing this by 3 to the negative 2, so 1 over 9 again, plus 2 to the negative 3, so 1 over 2 to the power of 3, so 1 over 8. Okay. Again, from here, all we're doing is adding fractions, so that would become, let's see, 4 and 9, the lowest common multiple between them is 36. So it will become, let's see, 9 plus 4, so 13 over 36 divided by, and then 9 and 8 would become, let's see, 17 over 72, just like that. And then from here, I'm just going to write an arrow. If you remember what I said earlier about dividing fractions, we just turn this into a multiplication and flip the other one. So it becomes 13 over 36 times 72 over 17. And then that can cross out to 1, that can cross out to 2, and we get our final answer to be 13 times 2, so 26, over 17. That would be our final answer. Let's do the next one real quick. 8 to the power of 2 minus 2n times 16 to the power of 3 minus n divided by 4 to the power of 2n to the power of negative 1. First thing we want to do is turn everything there into a common base. And a common base between 8, 16, and 4, I hope you guys see it, it's 2. So, this becomes 2 to the 3 to the power of 2 minus 2n times, this would be 2 to the 4 times 3 minus n divided by, and then this would be 2 to the 2 to the power of 2n to the power of negative 1, just like that. And from here, it's just exponent laws. So, exponent to an exponent, we multiply. And don't forget to multiply it all the way through. So in this case, it would be 3 times 2 and 3 times negative 2n. So 3 times 2 is 6 minus 6n. Let's do this bracket now. 4 times 3 becomes 12, and 4 times negative n becomes negative 4n. Let's do this one. So 2 times 2n becomes 4n, and then times negative 1 becomes negative 4n. Perfect. And from here, we can simply simplify. So when we're multiplying exponents with the same base, we add the exponents. So this becomes 2 to the power of 6 minus 6n plus this exponent right here. So plus 12 minus 4n. And we're just dividing it by that. And from here, we can simplify this top. So 6 plus 12 becomes 18. And then negative 6n minus 4n is negative 10n. So 18 minus 10n divided by 2 to the negative 4n. And again, an exponent rule, when we divide exponents with the same base, we subtract. And since we're subtracting a negative, we're really just adding it here. So this becomes 2 to the power of 18 minus 10n plus 4n, just like that. And our final answer becomes 2 to the 18 minus 6n. And that is our final answer for this question. Let's do the next one. Again, I'm going to do this one like I did that one, where I separate it. So this becomes 2 to the negative 1 divided by 2 to the negative 2 minus 2 to the negative 3. 2 to the negative 1 is 1 over 2. Dividing that by 1 over 4 minus 1 over 8. So here we're getting 1 over 2 times, actually I'm going to keep it simple for now, 1 over 2 divided by negative 7 over 8, I think. No, sorry, that's wrong. This just becomes 2 over 8 minus 1, so divided by 1 over 8. Just like that. So then it becomes 1 over 2 times, and we're going to flip 1 over 8, so 8 over 1, or just 8. And we can cross out that to become a 1, that to become a 4, and our final answer is 4. Let's move on to the next. I think these are the last ones, actually. So here, let's just run that exponent through to everything. But before we do that, we notice that it's negative. So this becomes 1 over a over b to the power of 3 times, and let's do this bracket at the same time. So exponent to an exponent, this has an imaginary 1, so 1 times 2. So a squared, and then 3 times 2, b to the 6. Perfect, and since we know that that's dividing, we can just flip it, so it becomes b over a to the power of 3 times a squared and b to the 6. And let's just run that 3 through. Actually, I'm going to do it on this line so I don't run out of space. So b to the 3, a to the 3 times that. And here, all we're really doing is saying, okay, well that's over 1, and we're multiplying them. So when we're multiplying, here we have the same base, b and b. So this can become 3 plus 6. So a squared, and then 3 plus 6 is 9. And all this is going to be over a to the 3. And then here, I hope you notice that, okay, well we have a, so we can actually cross these out, or we can subtract. So this can actually become, we can fully eliminate this whole thing and turn this into just a. So it becomes b to the 9 over a, just like that. And basically what I did there was I said, okay, this is a squared b9 divided by a to the 3, right? 2 minus 3 is negative 1, so it's a negative 1 b9. And a to the negative 1 is 1 over a times b9. And this 1 is invisible really, so it's b to the power of 9 over a. And I just skipped that step, but I showed it to you. Okay, let's do the next one. 5a to the negative 1 times b divided by c to the negative 2. So I'm just going to change this into 5a negative 1b divided by c to the negative 2. I just change it into divided by so it's easier to understand what's happening. 5a to the negative 1 just becomes 1 over 5a. And since we're multiplying it by b, we just put that on top. So b over 5a, and we're dividing it by c to the negative 2 just becomes 1 over c squared. And then this becomes b over 5a times c squared, because we're just flipping that and changing this to a multiplication. And our final answer becomes bc squared over 5a, just like that. Okay, let's do the last three. These ones are pretty simple. 1 over 4 to the power of 1 over 2, just the square root of 1 over 4, and it's 1 over 2, just like that. This one right here becomes negative. And real quick, what is the third root of 27? Well, it's 3. And the third root of 125, well, that's 5. So our final answer is negative 3 over 5. This one right here, we want the square root of 1 over 4 because it's a negative. And then this just becomes square root of 4. And we are left with 2 as our final answer. Anyway, I hope you guys enjoyed that. Hope maybe it taught you like some, solving ways, some solutions. Cut. I'm gonna redo that. Okay, and finally 1 over 4 to the negative 1 over 2. We see there's a negative, so this becomes 1 over 4 to the power of 1 over 2. And 1 over 4 is basically just saying 4. So we are taking the square root of 4, and we get our final answer to be 2, just like that. Anyway, I hope you guys enjoyed. I hope this video sort of showed you how to tackle some problems, some hard ones, some easy ones, anything like that. If you enjoyed it, leave a like, I guess, share it if it helped you, and yeah, have a good day.